Starting our new unit today, we're talking about verifying trigonometric identities. And these first identities should look fairly familiar to us. We know, as we talk about reciprocal identities, we know that the reciprocal of sine is cosecant. So when we're looking at reciprocal identities, sine can be rewritten as 1 divided by cosecant theta. And cosecant can be rewritten as 1 divided by sine theta, because they are reciprocal identities. Same idea happens here with cosine. Cosine has a reciprocal of secant, so 1 divided by secant will give us a reciprocal identity. And because cosine and secant are reciprocals, we could also rewrite secant as 1 divided by cosine. When we talk about tangent, tangent is 1 divided by cotangent. Those tangent and cotangent are reciprocal identities, so 1 divided by cotangent is the reciprocal, and consequently cotangent can be rewritten as 1 divided by tangent. But the thing about tangent is we know a little bit more about tangent. Tangent is sine divided by cosine, and cotangent is cosine divided by sine. And you will be responsible for knowing these reciprocal identities, as well as Pythagorean identities that we work through here in a couple minutes. And speaking of Pythagorean identities, what we did in our last unit is we started with the right triangle and the unit circle, and we said that to find this point that's given on the circle, that random point there, what happens is we started at the origin and we went over a distance of x, and then we went up a distance of y to get this point here of xy. We're starting with this right triangle on the unit circle, and the unit circle has a radius of 1. Pythagorean theorem is x squared plus y squared equals, let's try that again. It's a squared plus b squared equals c squared. And when we take what we just found here, we know that one of the sides of the triangle is x, so let's say x squared. One of the other sides here is y, we could square that, and then 1 squared. And then lastly, what we know is on the unit circle, cosine is represented by the value of x. So this is going to be cosine squared of theta. And then sine is going to be represented by y. And then we get 1. 1 squared is 1. And that's one of our Pythagorean identities. If we fill in this box here, it's typically, if you look on the internet, what it says is sine squared plus cosine squared theta equals 1. Although, as I've looked on the internet, I have seen it written as cosine squared plus sine squared equals 1 as well. Either way is fine in terms of the Pythagorean identities. We're familiar with that one. We used that all of our last unit. But from that identity, and I'm going to scoot this down a little bit, from that identity, we can come up with 2 more Pythagorean identities. And so if we take sine squared plus cosine squared equals 1. And we divide everything in this equation by sine squared theta. What happens when we simplify those values here? Sine squared divided by sine squared will be 1. Cosine squared divided by sine squared, well, cosine divided by sine is cotangent square root of theta. And then there's our reciprocal identity. 1 divided by sine squared is cosecant squared theta. And that's another Pythagorean identity now. 1 plus cotangent squared theta equals cosecant squared theta. We can take the same idea to find a third Pythagorean idea. We take our original, our sine squared theta, plus cosine squared theta equals 1. And this time what we're going to do is we're going to divide everything by cosine. Divide by cosine squared theta here, divide by cosine squared theta here, and divide by cosine squared theta there. And when we simplify that, sine divided by cosine, again, if we look up there in our quotient identities, we see that sine squared divided by cosine squared is tangent squared. Cosine squared divided by cosine squared is 1. And then here's our reciprocal identity. 1 divided by cosine squared is secant squared. And that's our third identity. Third Pythagorean identity, to be more specific. So let's take these Pythagorean identities and rearrange them a bit here. And we've got sine squared theta plus cosine squared theta equals 1. We know from our last unit that what we did is we said, well, sine squared theta equals 1 minus cosine squared theta, and cosine squared theta equals 1 minus sine squared theta. We actually particularly use those bottom two that we just filled in our last unit a lot. This time we can even use the sine squared plus the cosine squared equals 1 when we get to our verifying our trigonometric identities here in our examples. Well, the next identity, the 1 plus cotangent squared theta equals cosecant squared theta, can be rewritten two ways here. And what can happen here is we can solve this identity for cotangent. And the way that we solve it for cotangent is we subtract 1 from both sides. And we get cosecant squared theta minus 1. The other thing that we could do, and I know you don't have enough space on your paper, but I will show it here at least so you can see it, is we can take this identity, the 1 plus the cotangent squared theta equals the cosecant squared theta. And what we can do is we can subtract cotangent squared from both sides. And we end up with 1 equals cosecant squared theta minus cotangent squared theta. And if you prefer, you can write it in that format, or you might write it as cosecant squared theta minus cotangent squared theta equals 1. It's the same kind of idea for our third identity, the tangent squared theta plus 1 equals secant squared theta. We can subtract 1 from both sides, so we get tangent squared theta equals secant squared theta minus 1. Or we can do what we did like we did on our second identity. We can take our tangent squared theta plus 1 equals secant squared theta. And we can subtract tangent squared theta from both sides. And we end up with 1 equals secant squared theta minus tangent squared theta. And if you prefer, you can write it in that format. Or we can write secant squared theta minus tangent squared theta equals 1. The identities that we've done so far, the reciprocal identities, the quotient identities, the Pythagorean identities, you will be responsible for knowing as we get to our test or quest, whatever we want to call it, for this unit. The next set of identities, the even and the odd identities, maybe not so much so. But what happens here is that we have negative angles in these even and odd identities. And it's just a little rule that we kind of have to know, but I think that they will be provided for you if we do need them when it comes to the time of a test or a quest or a quiz on these. But what happens here is that sine of negative theta is the same thing as negative sine theta. And we can do the same thing for cosecant. Since we bring that negative out in front of the function, we can bring it out in front of the function for cosecant. And it turns out that it works the same way for tangent. Tangent of negative theta and cotangent of negative theta, we bring those negatives out in front of the function. And then the nice part here for the cosine of negative theta and the secant, secant of negative theta, is that we just end up with cosine of theta and secant of theta for these even and odd identities. So let's work through a couple of examples here. And before we get to those, a couple of helpful hints. Pick one side of the equation to work on. Pick the more complicated side. Oftentimes it tends to be the left side, but it's not always the left side. You can only work on one side. So you're picking the most complicated side, and you're going to take that side and you're going to turn it into the other side. It means no moving terms from one side to the other. Our goal is to get one side to match the other. We have to use substitution and algebra skills to make it happen. So that means that we've got to use some factoring skills sometimes. And then finally, all of the equations will be true. I'm not trying to trick you. I promise. So as we take a look here at our first problem, what we're going to do is we're going to use a reciprocal identity. And sine of x, I'm going to take the left side, it's more complicated. We're going to take cosecant of x and we're going to turn it into its reciprocal function, which is 1 divided by sine of x. And ultimately what we're trying to do is we're trying to get our left side of the equation to equal the right side of the equation, which is 1. When we multiply these two together, remember we multiply the tops of the fraction together and the bottoms of the fractions together, and we end up with sine x divided by sine x, and then sine x divided by sine x is 1. And there what we just did is we verified, we proved that the left side of the equation equals the right side of the equation. Problem number 2. We have to use an even odd identity because we have the secant of negative x. But when we start, there's nothing that we can do with cosine of x. But secant of negative x, if we look back here at our even odd identities, the secant of negative theta is the same thing as secant of theta. So we're going to turn that into secant of x for our first step. Then our second step is that we're going to use our reciprocal identities. So we've got cosine of x, and then secant with the reciprocal identity is 1 divided by cosine of x. And again, what we're trying to do is we're trying to turn this into 1. And now it becomes very similar to our first example because we're going to multiply these two together. I'm really sorry about the smartboard. But when we multiply these together, we're going to multiply the tops together and we're going to multiply the bottoms together. We end up with cosine of x divided by cosine of x. And then finally, well, what does cosine of x divided by cosine of x equal? It equals 1. And once again, we ended up, as we simplified the left side of the equation here, the more complicated side, we were able to turn that into 1 on the, which is what we have on the right side. Again, looking at these, we want to use our algebra skills. We want to use our Pythagorean identities. We've had to use our reciprocal identities. We even had to use an even-odd identity. In this particular case, we're going to have to use our Pythagorean identity. And as I flip back here for a moment, it says 1 minus sine squared on here. I went too far. But 1 minus sine squared over there on the left-hand side, 1 minus sine squared equals cosine squared. So we can use substitution here to fill that in. 1 minus sine squared, using substitution, is cosine squared of x divided by cosine of x. We started with the left side because it is the more complicated side. We're trying to turn this into cosine of x. And what might be helpful for you is to realize that something squared means times itself. So cosine squared means cosine of x times cosine of x. And that's all divided by cosine of x. And when we simplify this, what we're looking at here is, do we have anything exactly the same on the top and the bottom? And what we have is we have a cosine x exactly the same on the top and the bottom, so we can cancel it out. And when we cancel it out, we verify our equation because we have cosine of x on the left side and we have cosine of x on the right side. Number 4. Sine cubed x plus sine of x cosine squared of x. Again, the left side is more complicated. And the first thing that stands out to me, and I hope that stands out to you, is, oh, we have a sine of x in both of those terms on the left side, which must mean that we can factor it. We're going to factor out the greatest common factor, sine of x. When we do, we had 3 sine x's, we took out 1, which means that now we have 2 sine x's. In our second term here, we had 1 sine x and we factored it out. So now we're left with cosine squared of x, and we're trying to turn this entire equation into sine x. We're trying to turn the left side of the equation into the right side of the equation. And here's the thing, again, as I flip back to the Pythagorean identities, going back to the blue here, and what we did in our last unit is we had to use the sine squared equals 1 minus cosine squared theta, or the cosine squared theta equals 1 minus sine squared theta. We can now use the fact that we've got sine squared theta plus cosine squared theta equals 1. And it's probably nice to have your yellow identity sheet out in front of you where you can look back at that easier. But if we look at the identity again that we're working with, sine squared x plus cosine squared x simply equals 1. Everything in that parentheses just equals 1. 1. We still have our sine x outside of the parentheses, but now look, sine of x times 1 is sine of x, and before we know it, we have this identity verified. Number 5. 1 minus cosine squared theta divided by 1 plus cosine of theta equals 1 minus cosine theta. Well, we use the greatest common factor on example number 4. We can't use the greatest common factor on problem number 5, but we can use our skills with factoring. And it's 1 minus cosine squared theta. That part of this equation can be factored. And it's the difference between 2 squares. So when we factor this, it's going to be 1 times 1. Cosine squared is cosine theta times cosine of theta. and it's the difference between two squares, different signs. And now what we look at is, do we have anything exactly the same on the top and on the bottom? Well, we've got a 1 plus cosine. 1 plus cosine theta divided by 1 plus cosine theta is 1. But now we can finish, because when we cancel that out, we get 1 minus cosine theta equals 1 minus cosine theta. Number 6. The more complicated side is still probably the left side. And what I see at the onset is that we've got secant x plus 1 times secant x minus 1. Let's multiply those two together. When we multiply these two together, we get secant squared of x minus secant of x plus secant of x minus 1, all divided by sine of x. And again, what we're trying to turn this into is we're trying to turn this into sine of x divided by cosine squared of x. And remember, we only pick one side, and we only use one side to turn it into the other side. Well, next thing that I notice is we've got minus secant x and plus secant x, and those two values are opposites and therefore cancel out, and we have secant squared of x minus 1 divided by sine of x. Again, we're trying to turn this into sine of x divided by cosine squared of x. Whenever I see a squared in a problem and we are working on the left side, I always wonder, is there a Pythagorean identity that might work for us? So as you look at your yellow paper and I flip it back here a couple screens, do we have anything that says secant squared minus 1? Well, it's over here to the far right in the red. Secant squared theta minus 1 equals tangent squared theta. We can substitute tangent squared theta back into our equation for secant squared x minus 1. So instead of writing secant squared x minus 1, we're going to write tangent squared x divided by sine of x. Well, that helped some, but we're trying to turn the left side of the equation back into the right side, and one of our other techniques for verifying something is to turn everything into sines and cosines. So let's take tangent and let's use the quotient identity and turn it into sine squared divided by cosine squared. That's tangent. What's happening here is we had tangent squared x divided by sine of x. Let's go the old school route and write it as sine squared divided by cosine squared, and then we're going to divide it by sine x over 1. And when dividing, don't ask why. Flip the second one and multiply. So now we have sine squared x divided by cosine squared x times 1 divided by sine of x. And remember, when we multiply these, we multiply the tops together and the bottoms together. So we end up with sine squared x times 1. And then we've got cosine squared x sine of x. And we're still trying to turn it into the value on the other side that I didn't write down, the sine of x divided by cosine squared of x. I think we're getting closer here. And what might help you once again is, what does squared mean? Well, squared means times itself. So sine x times sine of x. And now we've got cosine squared of x times sine of x. And do we have anything exactly the same on the top and on the bottom? Well, we see we've got a sine of x here, we've got a sine of x here, so that leaves us with sine of x divided by cosine squared of x. And as I look over here to the other side, what we see back in the beginning of our problem is that that's exactly what we were trying to turn the other side into. Wacky smartboard. Again, sorry for the smartboard, but there is a typo on your paper on this one, and yours says minus cosine squared of x. So change that minus to an equals here for starters. And now we can verify. And verify means that we're going to take one side of an equation and turn it into the other side. We only work with one side. And as I think about it here for a second, the question is, do we want to distribute that sign first? Let's say yes. So we're going to multiply here. So this is going to give us sine of theta times cosecant of theta minus sine of theta times cosine of theta times tangent of theta. And what we're trying to do is we're trying to turn this into cosine squared of theta. Well, let's look at cosecant and use the reciprocal identity. So this is sine of theta times 1 divided by sine of theta. And let's go ahead here. It looks like what we're doing is turning all our values in this equation into terms of sine and cosine. So notice when I got the tangent there, I used the quotient identity, which says that tangent is defined as sine divided by cosine. And now we can multiply. And when we multiply, we're going to multiply the tops together, we're going to multiply the bottoms together. So sine times 1 is sine of theta. 1 times sine is sine of theta. And over here, we get sine times sine is sine squared theta. But we also have that cosine thing. So I just multiplied sine times cosine times sine. Sine squared times cosine. Down here in the bottom, 1 times cosine is cosine. And eventually what we're trying to do is we're trying to turn this into just cosine squared theta. Well, sine divided by sine is 1. And when we look at our second term here, do we have anything exactly the same on the top and on the bottom? Got a cosine. So this is going to be 1 minus sine squared theta. And again, we're trying to turn this into cosine squared of theta. Well, whenever I see squared, I want to look and see, is it a Pythagorean identity? So if we go back here to our Pythagorean identities, and you can look at your yellow paper, if we go back to our Pythagorean identities, what we see is one that we're fairly familiar with, is that 1 minus sine squared over to the left here on our board, 1 minus sine squared theta, does equal cosine squared theta. So we can substitute that in instead. So we get cosine squared theta. And there we match up with the other side of cosine squared theta.